Oxidation reactions in alkyne proceed again quite similarly to those in alkenes, with some intricacies again introduced by the fact that we now have possibility for double reaction only. So if we have an alkyne and expose it to potassium permanganate, presence of water, then we'll get us a compound which has 4 OH groups attached to the former carbons of the triple bond. But compounds which have 2 OH groups attached to the same carbon are typically unstable, and so they lose water to give things like this, basically diketones, which is the final product of it. In cases when we have terminal alkynes, by the same token, the final product of our oxidation is this aldehyde. But now aldehydes themselves can be oxidized, so the oxidation does not stop here. Instead, it goes all the way to the carboxylic acid, as shown here. Okay. Now, in cases when potassium permanganate is too concentrated, this reaction will overshoot, just like it did with alkenes. So, in those reactions, we will get the cleavage of alkynes, and we'll typically get 2 carboxylic acids. If we have a terminal alkyne, then one of the acids will not really be an acid, but instead we'll get the molecule CO2. Finally, alkynes are also subjected to ozonolysis, and again this results in cleavage. In this case, the reductive treatment is relatively rare, so most of the time this is meant really to establish the position of the triple bond by forming 2 acids. And so this is not the reductive treatment that gives us carbonyl compounds. Instead, the reduction goes all the way, the oxidation goes all the way to give us 2 carboxylic acids. So this is pretty much it when it comes to the reaction of alkynes. You see that they're very similar to the reactions of alkenes, but there are certain differences which mostly come from the fact that the presence of substituents on a double bond now makes this arrangement a little bit different, and then leads to tautomerizations and similar reactions. In the next subtopic, we'll see how these and other reactions combine in synthesis to provide the routes to relatively complex molecules from simple precursors.